In this video, we are going through an important part of the PCB design process, which is basically generating the output files that are needed for manufacturing. We have already designed the board, laid out our components, and routed the traces, which we covered in the previous video. Now it's time to prepare everything to send off to our chosen fabrication house and assembler. So essentially bringing the PCB design to life. Speaking of bringing designs to life, I'm super excited to have PCBWay as the sponsor of this video. They offer PCB manufacturing and assembly services with quick turnaround and competitive prices. You can upload your Gerber files directly, choose your board specification, and get an instant quote. Don't get hung up on choosing the color of your PCB, there are many options to choose from. They support a wide range of options including multi-layer boards, flexible PCBs, and assembly for both surface mount and through-hole components. PCBWay also hosts a shared projects community where designers can share their work and browse open source projects. It's a good resource if you're looking for inspiration or reference designs. So once again, thanks to PCBWay for supporting this channel and sponsoring this video. You'll find a link in the description if you'd like to try them out for your next project and get a bit of a discount for yourself. I also share my projects on the PCBWay community page, so you can check out my projects there too if you want to order them for yourself. Now, back to the video. So the PCB that we've designed is this one over here, which is a ESP32 based drone that we have been following. So it's a reference design that I'm using for the purposes of this tutorial. Obviously, you can see I've laid out all the components and the tracks. I sort of glossed over in the past, but I did show you how to do all of this. But we can have a quick look at the design as we go through this. So you can see I've got my USB-C connector and the switch over here, the 4 connections for the motors in the corner, my ESP32, my gyroscope IMU, my battery connection, and on the back side I have my VBAC connections for the motor, which is a nice thick copper pore going all the way around from the battery connection to basically the motors and the MOSFET drivers that we are using for the motors. So before we jump in, make sure your PCB layout is complete and you have done your design rule check. So I think we covered this in the last video, and you can see I've got some errors in here, but that's just because my library, I've moved things around. Make sure you resolve all your errors and you look at the warnings before you continue. So with KiCAD 9, they have introduced a very good new feature, which is called a job set. Now to create a job set, you go to your main KiCAD window, press the file button, and click on new job set file. You have to give your job set a name. So I'm going to call this manufacturing pack for the time being. Press OK. And what happens is you will get a secondary tab on your main screen, which will have the name that you gave the job set. Now, what is a job set? So what this allows you to do is create multiple different outputs with the click of a button. So in order to get your PCBs manufactured and assembled, obviously you need to generate Gerber files, you need to generate assembly files, you need to generate bill of materials and everything like that. What you can do is automate that with the job set function. So very handy. Now, before I do it with the job set, I want to show you how to do it without the job set as well, just so you understand the process and what's happening when we do the job set setup. So first thing, let's look at the bill of materials. For the bill of materials, I'm going to open my schematic editor, and then I'm going to click the bill of materials button over here. So this says generate bill of materials. From there, what you want to do is go into the edit tab. Now your layout might not look like this, but generally you want this ID or item number enabled, which I think might not be enabled by default. And then you want to bring that to the front. You want your reference designators enabled. You want your value enabled. You want the quantity enabled as well. And if you remember, I spoke about a different way I manage my libraries, and I still need to show you a video on how I create my components. But essentially, the way I create my components allows me to generate a bill of materials with all the information I need for the assemblers to build it properly. So you can see I have a manufacturer tab. I have a manufacturer part number, which I got a spelling mistake on this one, so I need to delete that. So I've got a manufacturer part number, got a supplier and a supplier part number, and also a package. So essentially, this is everything I need to get this PCB assembled. Now, after this, what I'm going to do is save this so that I can use it in the future. So click on View Presets and click on Save Presets, and you can give it a name. And next time you come around to do this, you can basically select the preset and it will set up the bill of materials window as you see it here. Now, I think this is per project, so I don't think the settings carry over into the next project. But there is a workaround for that, and I will show you that when I go through setting up a project template for you guys. Next, what you want to do once you have all your columns set up properly, you want to go into your export tab, make sure you select your output location. So in this case, I've got ESP drone main PCB, and in there, I'm going to create a folder. So ESP32 drone outputs, I'm going to create a bill of materials folder inside there, and then click the save button. After you've created your folder, so my folder is called ESP32 outputs, and inside there I have a bill of materials folder. I'm just going to click export. Now if I go into my ESP32 drone project, and I think this is ESP32 main PCB, in there I have the outputs folder that I've just created, and in there I have the bill of materials folder. Now I have done this previously because I have already ordered the PCBs and I've got them to hand, which I will show you in another video. So bill of materials, and you can see I've got my CSV file over here, which I just generated. And this is what the CSV file looks like. And you can basically pass this off to the assemblers and they will be able to use it to get your boards assembled for you. It has all the information that they need. Next, I'm going to show you how to generate the Gerber files. And for that, you want to go into PCB editor, then click on the plot button, which is over here. And then in the plot button, you can select your format. So I go for Gerber. There are other formats that you can use. And in the include layers, you want to include all the layers that are necessary for your boards to be built up. So you can see I don't need user comments or user drawings for my board. Everything else, I want it ticked. You want to select your output directory and then click the plot button. I normally don't worry about any of the other settings. Next, you want to generate your drill files. And to do that, you want to click this button over here. Select your path. I go for Epsilon format, which is fine for PCB way. And then click generate. So that will have generated the Gerber files for us as well. So I've got another folder in here called the Gerbers. And you can see all of these files were just generated now, except for these two, which I basically chose not to generate. Next, what you want to do is if you have a board that you want to get assembled as well, you need to generate the component position files. And to do that, you want to go into File, Fabrication Outputs, and Component Placement. And generally, I click on Include Only SMD Footprints because that's what I want assembled. But make sure you've clicked the right settings that you need over here. If you have any SMD components with through-hole pads that you don't want included on the assembly, you can tick this button over here as well to get rid of them. And you can exclude all do not populate parts as well. Now, similar to how we generated the Gerber files, you want to choose your output directory and click the generate position file. Now, if I go into my folder for this, so I've got a folder called POS, and in there, you can see I've got two files that I just generated, and one is the top layer and one is the bottom layer. Now, you can see on my PCB, I don't have any components on the bottom layer. So what I'm going to do is go into my folder and delete the bottom position file because I don't need it. So now we have generated our bill of materials, Gerbers, and position file for the components. There is a cool add-on that you can have for a interactive bill of materials. And in order to get that plugin or that add-on, you basically go to your KiCAD main window, click this plugin and content manager button over here. And then you want to install interactive HTML BOM. Once that's installed, you basically click install and apply pending changes. Once the add-on is installed, you can go into your PCB editor And you can click this button over here, which says Generate Interactive HTML BOM. And what that lets you do is basically create a bill of materials that is a lot easier to look at, and it's very useful for debugging and solving problems on your PCB. So obviously the name over here, you can change it to ESP32 drone. And you can see I've got my folder already selected as iBOM, which is the interactive BOM. Now this BOM I generally don't need to send to the PCB manufacturers, and it's for myself only. You can include your tracks and nets if you want to as well, which can help with the debugging. So what I'm going to do next is click the Generate BOM button. And you can see if I go into my iBOM folder, I have a new file over here that's generated today, which is this one over here. And I'll show you what that looks like. So if I double click on that, you can see I've got an interactive version of my PCB, which I can zoom in and out of. I've got a nice render of the PCB, or a outline of the PCB with all my silkscreen layers and everything included. I can change the layout around if I want to, which is very handy. I can see just the back of the PCB, or front and back. Obviously, I just care about the front. So I'm going to zoom out of this PCB a little bit and show you what's on this side. You can do ungrouped or grouped for your component list, and once you hover over your component, you can see all the components highlighted. So right now I'm looking at a 2.2 microfarad capacitor, and on the right hand side you can see that the 2.2 microfarad capacitor is highlighted everywhere that it's used. And obviously you can do the same thing for all the different components on the PCB. So this is very useful if you're troubleshooting, or maybe if you're building this PCB yourself. It can be very useful to see where all the components are, but you would need your PC to hand. So the interactive BOM is very useful and generates a very cool bill of materials for you to look at. Now if I go to my outputs folder, we have done our bill of materials, Gerbers, the interactive bill of materials, and the position. Now if you don't want to use the interactive bill of materials, you can also generate assembly drawings with KiCAD. Now the way I do this, and I'm sure other people do it slightly different way, is I use my fabrication layer and the print function. And this involves having to manage your libraries again. So when you're generating your footprints, you want to make sure there's no unnecessary data on your fabrication layer for this to work. So I go into print, I select my edge cuts, and I select my front fabrication layer, and then fit to page. Now if I click print preview, you can see on the screen I've got my PCB with all the components in its location, and obviously this is very useful during assembly. So I'm calling this basically the assembly drawing, and you can print this with the border as well if you want to, by clicking the print drawing sheet over here. So a very handy assembly drawing if you manage your footprints the way I do it over here. I'm sure there are other ways to do this as well, but on this you have all your pin 1 identifiers, you have your component identifiers and everything all managed on the fabrication layer. So that is everything you need in order to get your PCBs manufactured and assembled. So let's now have a look at a way of automating that task, which is basically the Jobset function. Next, I'm going to set up a outputs folder, again similar to what I did for the manual file generation. In the outputs folder, obviously we want 4 folders. So that's going to be Gerbers, assembly, and drawings. So with that in mind, let's go back into the Jobset file. And what I'm going to do first is create a folder, or a output folder thing over here. And for that, I'm going to go in and select my Gerber folder and press the select button. Description, I'm going to call this Gerbers. So you get the Gerbers description over here with the file location that we just selected. And then I'm going to press the plus button, select PCB export Gerbers, press OK. And in there, I obviously want all the layers that I previously generated for the manual operation. Press the OK button on that, and then press the plus button again. You want to go export drill data. Similar to before, press OK. On the right hand side, you want to click the little gear icon and make sure those two are ticked. So that's our Gerbers. Now if I go into here and save the job set and generate the output, you can see in my Gerber files, I've got all my files generated with that button there. So that includes my drill files as well as the Gerber files. Next, what I'm going to do is create another folder on the right hand side by clicking this plus button. Actually, before that, let's create the jobs again. So I want to go into the plus button. I want to export a 3D model. So in a step file, I'm going to call this ESP32 drone. And obviously you might not need this. Create it if you need it. If you don't, you can just leave it as is. So that's a 3D model export. I am going to also generate a position data. So PCB export position data. Just press the OK button on that. Include only SMD footprints. And then I want to create my bill of materials. Obviously, previously we created our preset. So I'm just going to click that again, my default. In the export tab, set up the delimiters as before. And then obviously you want to leave the output file as it is. I'm going to call this ESP32 drone bomb.csv and press the OK button. Next, I'm going to press the plus button again and go into schematic and export PDF. For that, I want to write ESP32 drone schematic and press the OK button again. So these are all the jobs I'm going to need for the time being. And then over here, I'm just going to create a new folder. And for that folder, I'm going to select my outputs and my assembly. Press OK. And then I want to untick Gerbers and the drill because we covered that in the Gerbers folder. I'm going to call this folder assembly. And in the assembly, I want to export the position data and the bill of materials. So press OK and we've got a assembly folder. Next, create another folder. For this folder, I'm just going to call them drawings. For the drawings, obviously, I want to select the drawings folder. And in there, I want the export PDF. Another folder, and this is going to be for the 3D model. Obviously, we haven't created a folder for this yet. So let me just quickly do that. So I've just created a step folder in here. So I'm going to select the folder, call this step file or something. Select my output step, press select folder. And in there, I just want the export 3D model option selected. Save the job set just in case this crashes because it is a bit buggy at the moment. So you want to make sure you're saving all the time. The last thing I need is the assembly drawing, which I haven't done yet. So for that, I want to go into PCB export PDF. And in there, I want to select edge cuts and F fabrication as we did manually. And I also want to select F fab on here and click the single document button. So that will allow me to generate the same document I did for the assembly. Press OK on that and you can see I've got another export PDF over here. And I'm just going to give this a name, call it assembly drawing. So it's easier to identify when we are working on the right hand side. So in drawings, I'm going to click the gear cog and I want to select 7. Press OK, save the job set. And you can see we already generated the Gerbers, but let me delete them. So all of these folders at the moment should be empty. So all I'm going to do now is click generate all outputs. And you can see I've got ticks next to all of them, which means that they've generated successfully. If they hadn't, there would be a exclamation mark there. So that's basically good news. So I have basically forgot to untick some things. So if you add in jobs after you create this folder, you basically have to go in and untick them. So I'm just going to do that. Make sure all of them are ticked properly. So I've just made my folders all empty again. And that reminds me, one thing I need to do is when you're creating schematics, obviously you give it a name, but you also need to add in .pdf. So I'm going to add the .pdf, press OK, save the job set, and I'm going to click generate all outputs. The load box is gone. That means I should be okay to kind of load up my files and see the output. So let's go into our assembly drawing first. So you can see we've got our top and bottom assembly. We've got our bill of materials as well. Obviously, we can have that in a different folder as well if you need to. I did mess up with the delimiters, so it's not exactly like we generated manually, but you can mess around with those settings to get that exactly as you need it. In the drawings folder, we have the schematic for the PCB. So this is basically what we have. Now the schematic that's generated over here is I don't know if you call it a smart schematic, but you can see it's got all the pages and you can basically just find your components, and it's smart in that you can navigate the schematic easily. You also have the PCB drawing as well. Obviously I'm calling this the assembly drawing. You can also print the outline or the sheet if you want as well. You just got to select that in the settings. So our Gerbers are generated as well, along with the drill file. And finally, we also have our step file that's generated. This Jobset file obviously makes it very easy to generate all your outputs. So what we can do once we have done this is turn this project or your baseline project into a template. And then you can use this for all your future projects as a starting template. And I'll show you how to do that in another video. So make sure you stick around for that. This is basically everything I needed to show you for this video. Obviously, we've covered quite a lot, and this video is going to be relatively long. So there you have it. We've covered how to generate all the essential output files from the KiCAD PCB design and the schematic, including the Gerbers, drill files, pick and place files for assembly drawings, and obviously the bill of materials. We've done that manually and using the Jobset function, which was introduced with KiCAD 9. And I think this Jobset function brings the software a lot closer to how Altium operates as well. And I really enjoy this feature, to be honest. It is a little bit buggy. I've had a few crashes on there, but it's not that common. So I think, definitely recommend using it. And I think as a final kind of warning, or maybe as a guide, make sure you check your Gerber files in a different Gerber file viewer, just to make sure that it's actually what you expect before you order your PCBs. Just because it's better to be safe than order PCBs that are wrong, just in case your Gerbers were accidentally flipped or mirrored or something like that, and you want to correct any mistakes. So obviously this video is focused on using KiCAD and not PCB design. So if you found this video useful, please give it a thumbs up, subscribe to the channel for more KiCAD tutorials, and hit the notification bell so you don't miss my next video. I would like to say a massive thank you to all the new members that have joined the channel. Your support is really appreciated, and it helps me to kind of design and order PCBs for testing. So thank you for supporting the channel. Leave any questions or topics you'd like to discuss in the comments below. See you next time.